the diver is entering the water, it's best, as from the moment he enters the water with the hose onto his mud chaser, we start up the main pump. That allows a few extra minutes while the diver is descending into his work position, that this hose will be running at 20 gallons a minute. It'll help flush air out of the system, on out of the hose, get the flow going good, get the DE filter up in good operating condition. So, now, the operator here closes down the control valve to about 20 gallons a minute. To 20 gallons a minute. That is the ideal pressure, ideal volume of flow down in the mud chaser. Okay, right now we're running 20 pounds of pressure on the discharge, 20 pounds of pressure on the 5 micron filter, and 22 pounds of pressure on the DE filter. Now there's going to be about 2 to 3 pounds difference because of the inactivity of the filter, but basically all 3 of them should be running the same. Now, the main job of the operator now is to simply make sure things keep running. If the cyclone filter starts getting filled, you can see it fill up in here, bleed it off. That cleans it out. You can have a hose tied onto that, run out over the side of the boat, whatever. Okay, we're operating. The diver's been in the water for hopefully several hours. And you notice the pressure difference. The first thing you're going to notice is this pressure is dropping. So you close this down. That forces more water to go down to the diver, which brings this pressure back up. But as you bring this pressure back up, it's also going to raise the pressure on the pressure gauges. Now, most likely or not, one pressure gauge will raise more than the other. Because as the filters get clogged, they start creating resistance. Now, diver's in the water. We're watching the system. Everything's proceeding along normal. Pretty soon this pressure gauge starts to drop. That's a sign we're getting some restrictions in the filter. Now, 2 things can happen. Either this filter plugs up first, or this filter plugs up first. But whatever happens, this pressure is going to drop down. And as you start cranking this down, pretty soon you're going to have this valve shut and you can't maintain 20 pounds of pressure. Now, you might have 25 or 30 back on these filters. So what you need to do is start up the booster pump and start closing down this valve, which what it does is, it does the same thing this valve does. It takes the flow that's passing through here, makes that pump work, starts drawing water through this system, which creates a low pressure area on this side, which allows then you raise your pressure up and your flow up, and keep the pressure and flow up together. As this starts to drop, then again, this is clear tight. You continue to trim this down until you get to a point that you can no longer maintain 15 to 20 gallons of flow through the flow meter. At that time, either one or both of these filters are going to be plugged up. So, by looking at the pressure gauges on the pumps, you can tell which one it is. If this pressure gauge is at 40 pounds, then you know this pump is doing all its work to try to push it through that filter. That's the filter's plugged. If this one is still down at 30 and that's at 40, that's the plugged one. If these are both up, if this is up to 40, 35 or 40, and that's at 35 or 40, pretty good chance it's this one's plugged up. Now, one advantage that you can tell between the two is we have a differential pressure gauge here It tells the difference between the inlet side of this filter and the discharge side. So as this filter plugs up, this pressure gauge will go up. And you know then, when this gets up into the change category, that this filter is beginning to plug up. That one might already be getting up there or might not be. It depends on water conditions you're in. Now, we will have a discussion later on how to clean these filters. But right now, that's the basic operation. Any questions? Thank you.